All right, this is 4.11 multiple choice exercises, and we're going to be going through these. How many are there? Oh, there's more at the bottom too. I can't tell how many there are. There's a decent amount. Usually there's like one at the bottom that tells me. Okay, it says 411, 1, easier multiple choice questions. These problems are easier than most of those you will see on the APCSA exam. Okay. Also remind me to take the quiz off of Aircross. Remind me, or else it's going to sit there. Okay, so what will this print out? Starts at 3. It's inclusive of 12. We can tell that pretty quickly, right? Starts at 3, inclusive of 12. Should print out 3 to 12. Check me. Correct. Okay, right here, starts at 3, but is not inclusive of 9. So it goes 3, 4, 5, 6, 7, 8. And it doesn't include 9, right? Because it's less than 9. So that gives me 6. Print system.out.print 6 times. So it should give me 6. What does the following code print? Notice that the plus plus is in front and it runs before, right? So if it starts at -5, it will run. The first thing we'll print out is actually -4, because if x is -5, -5 is less than 0. It will run, but it will add 1 to it first, which gives me -4. -4 prints that out. So given this is the only one that starts with -4, right? And -1 will run. It adds 1 to it, which is 0, which is the last one in this set right here. So it should be C. How many times is the following print an asterisk? So it's 5. It's inclusive of 12. So 5, 6, 7, 8, 9, 10, 11, 12, 8 times. So the answer would be B. How many times does the following method print an asterisk? Starts at 1. It's not inclusive of 5. So it goes 1, 2, 3, 4, right? And stops there because it doesn't run for the 5. So it would be A 4 times. How many times does the following method print an asterisk? Okay, it starts at 0, inclusive of 8. So 1 to 8 would be 8, but 0 to 8 would be 9, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, right? Which was actually 9 that I've counted on my fingers too. 9. So that would be C, 9. How many times does the following print an asterisk? Starts at 0, but stops before it gets to 5. That's my favorite way of writing for loops, is starting at 0 and then having less than the number of times that's supposed to go through, because that easily lets me know that it's going to be 5 times. So this will run 5 times. How many times the following method print an asterisk? Goodness gracious, how many of these problems are we going to go through? 2, 3, 4, 5, 6, 7. So it should be B7. Oh, sorry. I'm not paying attention. Starts at 2. 2, 3, 4, 5, 6, 7. I counted to 7 out loud, but I put up 6 fingers. Sorry. See, I was moving too fast. I put up 6 fingers, but counted to 7. Okay. What does the following code print? If I have my while loop now, starts at 0. It's inclusive of 5. So it should print out 0, 1, 2, 3, 4, and 5, because it includes 5. 5 is less than or equal to 5. So it should be D. What does the following code print? It starts at 3, as long as it's less than 9. 4, 5, 6, 7, 8. I put up 6 fingers, but what's going on here? There's no increment operator. So X is assigned 3. 3 is less than 9, print this out. 3 is less than 9, print this out. 3 is less than 9, print this out. So it's a forever or infinite loop and goes on forever. All right, a little bit harder now. Got a nested for loop. Okay, how many stars are output when the following code executes? So look at the top one. This is going to be 5 rows by 5 columns. 5 times 5 is 25. Is that right? Yes. Which of the following code segments will produce the output? Okay, I'm trying to print out 1, 2, 2, 3, 3, 3. So 4 4s and 5 5s. 1 1, 2 2s, 3 3s, 4 4s, 5 5s. Okay, so the first loop is going to start at 1. Let's look at this one. Let's see if this one works. So it starts at 1 and gets incremented by 1 each time as long as it's less than or equal to 5. That's going to include all 1 through 5, so that looks good. Int j is assigned I. As long as j is greater than 0, subtract 1 from it. Okay, so that would, to me, that does not look right. Let's move on. How many options? They gave us 5 different options. So I don't think one, okay, so it's only one of these. So the next one, we have 0 to 5, but it doesn't include 5. That one doesn't look right from first glance. Let's look at this one. Starting at 0, yeah. Let's look at this one. This goes to 1 and doesn't include 5 either. This starts at 1 and does include 5 as long as j is less than I. Well, will j always be 1 less than I in that case? Maybe I should, this one will print out. This one also has a print line after every single one, so it can't be 4. Let's look at this one down here. This one says I is assigned 0. I is less than 5. So we'll go through 5 times. Every time we're printing it out, we're printing I plus 1, which would make sense because that would give me 1, 2, 3, 4, and 5 that we're printing out. How many times we print it out is the question. As long as j is less than I, j is 0. Will j ever catch up to I, though? That's the real question there. Let's look. So if j is, we'll walk through this one, walk through it. So if j is 0, is 0 less than 1? Is 0 less than 0? No. Because if j is 0 and I is 0, then that wouldn't run. So that can't be the case. So it can't be 5. Can't be 4 because we're not printing something on the same line. We're print lining every single time. Let's look at this one. 1. We're printing up all the way to 5, right? Yeah. So we'll see, we'll look at 3. So if I have I is assigned 1, I is less than 5, that runs. So J is assigned I, and as long as J is greater than 0, we're subtracting 1 each time. But that wouldn't make sense because if J is assigned I, then I is 1, right? We're incrementing that. All right, let's look at this deeper. I is assigned 1. 1 is less than 5, so it runs. J, get my note card out here. Okay, I is assigned 1. J is assigned whatever I is, which is 1. Is 1 greater than 0? Yes. So it subtracts 1 from J and gets down to 0. It then prints out I, and I is 1. So it would print out a 1. Then to loop back through, okay, is 0 greater than 0? The answer would be no, it is not greater than 0. So that would only run 1 time there. The next it would go through is 2. Is 2 less than 5, right? Yes. Okay, so it would assign J would be 2. Is 2 greater than 0? Yes. It subtracts 1 from it. And it prints out 2. Then we go through again. Is 1 greater than 0? Yes. So it prints out once again the 2. So it looks like 3 is going to be our answer. Let's check it. Oh, went too early. I see, because eventually it's not inclusive of 5. I see. So let's look at the top one then. Yeah, the top one must be it, because that's inclusive of 5. So the difference between these two right here are just this goes through 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, 4, 4, 4, and then stops, where this one goes through 5, 5, 5, 5. Let's try 1. Yeah. So that was the problem with 3. 3 wasn't inclusive of 5. Okay. So as you see, that's one way of writing it. We didn't write the loop like that before in our last example when we did something similar to that. That's a harder one. Okay. The more we go through of the better we'll get. Okay. Next one, it says int k is assigned 0. As long as k is less than 20, we're going to add 2 to it. Okay. So k is 0. If you take 0 divided by 3, right, you get 0. So that's not a remainder 1. But if it is, then print out whatever that number is. So 0 doesn't work. 1 should work, right? 1 divided by 3 gives you a remainder of 1. But 1 is not odd because we're adding 2 each time. So 1 would not actually work, because if I have k is assigned 0, the second iteration would be 2. So is 2 divided by 3 1? No, so it's not added. Add 2 to it. Is 4 divided by 3? Does that give me a remainder of 1? 4 divided by 3 would give me, remainder 1. So 4 would go in that list. 6 divided by 3, it divides evenly, so the remainder should be 0. 8 divided by 3, the remainder would be 2. 10 divided by 3, the remainder would be well, 10 divided by 3 would be 9 divided by 3 would be 0. 10 divided by 3 would work. So it'd be 4. 10 would work so far. So this must be the answer because we have 4 and 10. Let's check it. That's correct. So start at 2, 4, 6, 8. Continue to divide by every even number. Let's see why 12 wouldn't work. 12 divided by 3 divides evenly. Okay. 14 divided by 3, that's remainder 2. So it looks like it goes remainder. It starts out at 0, so it goes remainder 0. Then it goes remainder 2, and then remainder 1. Remainder 0, remainder 2, remainder 1. Remainder 0, remainder 2, remainder 1. And that's 4, 10, 16. All right, another fun one to go through. 4, 11, 14 says, which of the following code segments will produce the displayed output? So I have 5 1s, 4 2s, 3 3s, 4 4s, and 1 5. I'm going to go through slowly. Each looks like there's 5 altogether, right? Let's go through these 5. Let's read through each loop slowly. Let's try to go through it. We'll keep going until we hit a problem with it. Okay, so starting off, I have J is assigned 1. And it says 1 is less than or equal to 5, as long as J is less than or equal to 5. So it does include 5, which is a good step. Each time we're going to add 1 to it. Okay. K is assigned 5. And it says, as long as K is greater than or equal to J, okay, is 5 greater than or equal to 1? And the answer is yes. So afterwards, I'm going to subtract 1 from it. So it should print out K, or it should print out J here, and J is 1. We then subtract 1 from K, which gives us 4. And is 4 greater than or equal to 1? The answer is yes. So it prints out the 1 again. And that then makes my K 3. Is 3 greater than or equal to 1? The answer is yes. So I go ahead and print out the 1 once more. We decrement 1 from 3, so K is now 2. Is 2 greater than or equal to 1? The answer is yes. So I print out another 1, and I take 1 away from K, so K is now 1. Is 1 greater than or equal to 1? Yes, it is. So I'm going to print out another 1, and then I'm going to subtract 1 from it. So K is now 0. Is 0 greater than or equal to 1? No, it is not. So then it moves on to the next letter. The next number. So now J is incremented by 2. Is 2 less than or equal to? So if J is 2 and K is now 5. Okay. If K is 5 greater than or equal to 2? The answer is yes, it is. So it prints out the 2. And then it does the same thing again where K is taking 1 away from K, which is 4. Is 4 greater than or equal to 2? The answer is yes. So it prints out the 2. The 4 gets knocked down to a 3. Is 3 greater than or equal to 2? Yes. So it prints out the 2, knocks K down to 2. Is 2 greater than or equal to 2? Yes, it is. So it prints it out and then knocks K down to 1. Is 1 greater than or equal to 2? No, it is not. Okay. So far, so good. The 3s will operate the same. Let's look at 5, right? When you finally get there, is 5 greater than or equal to 5? Yes, it is. It looks like 1 works. Let's try it. Correct. I'm glad it worked because I don't want to go through that and then have to go through another one. but this one works. Let's see why these don't work. Let's see if we can figure out on first glance. Well, this one won't work because it's print line instead of print each time. So 4 doesn't work for that reason. 2 doesn't work. Let's see the difference between 1 and 2. 2 doesn't work because we're comparing it if it's greater than or equal to 1 instead of j. 3 doesn't work because it's saying it's starting at 1 and it's less than, it'll add up. That will end up being an issue in the end because that would print out. That would be like the exact opposite, where it would give you 1 1, 2 2s, 3 3s, 4 4s, 5 5s. 4, we gave a reason why, because there's no print. And this one, let's see why this one doesn't work. This one also is less than or equal to 5, but we also are assigning k to j each time. Okay. Last one here for 11:15. Okay, starting off, it says that there's a variable 1 that's assigned 0, a variable 2 that's assigned 2. Oh, they made it. Why didn't they just call it var 0, right? Okay, it says while var 2 is not equal to 0, okay, is var 2 not equal to 0? Var 2 is equal to 0. So it's an and conditional. So that while loop, well, let me see. So var is not, okay, var 2, I'm sorry. var 2 is not equal to 0. var 2 is 2. Okay, and var 1, 0 divided by 2. If you take 0 divided by 2, that gives you 0. Is 0 greater than or equal to 0? Yes. So true and true. So it goes through and says var 1 is assigned var 1 plus 1. So var 1 was 0, but now var 1 is now var 1 is 1. Var 2 minus 1 was 2, but now var 2 is 1. Okay. Let's run through this again. Var 2 is 1 not equal to 0? True. And var 1 divided by var 2, so 1 divided by 1 is 1. Is 1 greater than or equal to 0? Yes, it is. So I take var 1 and I add 1 to it. So var 1 would be 2, and var 2 would be 0. Okay, so it's going to say run, is 0 not equal to 0? No, that's false. And it's an and compound condition there. So I stop there. It says, what are the final values? Well, var 1 I have written down as 2, and var 2 I have written down as 0. So let me try D. Let's see if that's right. Correct. Okay. I have to write these things down. I can't do them in my head. I just can't. There's some extra practice if you want to use that. The mark green button check mark our intention on including this page because there may be many quiz bank exercises. Okay. For more practice, you can go there. And that is 411. Now, you guys can